magnetic quantum number. Magnetic quantum number. What is magnetic quantum number? Magnetic quantum number basically tells about the direction, or you can say gives the orientation of an orbitals in a space. That is called magnetic quantum number, and it is represented by m. Like, to identify the shells like K, L, M, N, and so on, to identify these shells we use the first quantum number, that is a principal quantum number. Then to identify the subshells like SPDF we use azimuthal quantum number. Then we are having in subshells we are having the orbitals, like at which axis they are present, what are the direction of these orbitals. To identify those we use magnetic quantum number. Like for example, we are having P, taking P subshell. So basically P subshell, there are axes, we know that there are axes, that is x axis, x negative, y axis, y negative, z axis, and z negative. In P subshell, one orbital found in on the x axis, that is one orbital, that is actually the one orbital. Second orbital is found on the z axis. Third it is found on the y axis. So we can say the orbital that is found on the x axis will be px, and the orbital that is found on the y axis will be py, and the orbital that is found on the z axis will be pz. So we have identified the direction of these, that of the orbitals, that where they are located, where what is the direction of these orbitals. To identify these we use magnetic quantum numbers. Now fourth one, we are having the quantum number, that is spin quantum number. What is a spin quantum number? It basically tells about the spinning of electron, about the spin of electron in an atom. Spinning of electron of an orbital in an atom is called spin quantum number, and it is represented by S. So basically there are two directions of spin. First one we are having clockwise, second one we are having anti-clockwise. Clockwise basically denoted like this, and anti-clockwise is denoted like this. So in one orbital there are, two electrons, clockwise as well as anti-clockwise. So if we are having like on the axis we are having two electrons in one orbital, this whole together is one orbital, but one electron, two electrons, so it is one orbital. So it is like positive and it is a negative. So one have the direction clockwise, it has the direction clockwise, and if it has a direction anti-clockwise. So to identify the direction of the spinning of an electron we use a spin quantum number. Okay, so clockwise is equals to positive 1/2, and the anti-clockwise is equals to minus 1/2. Why? But they have a one electron, but how they are 1 upon 2? So it is, this is actually the half electron, sorry, half orbital, and this is actually the half orbital. So that's why we are writing 1 upon 2 and 1. Totally we got a 1 orbital. Clear? Now we got an MCQs here, that it can come a question I am going to write. It's important, that which one is correct. So there are 3 shapes. One I am going to make, second 3 I am going to make shape. One is having both clockwise, second both anti-clockwise, and one clockwise, one anti-clockwise. So they can ask that which one is correct. So you have to tell that which one is correct. This is both clockwise, this is anti-clockwise, and these are both clockwise as well as anti-clockwise. So which one is correct? So the correct option will be this, clockwise and as well as anti-clockwise. How? The reason I have shared, one is clockwise and second one is anti-clockwise. If there will be both the direction have like this, both have the same direction, so they will be going in the same direction. So due to the repulsion, it will not exist. Same here in anti-clockwise, if they both moves in a anti-clockwise direction, they both got a repulsive force. There's a repulsive force, and due to the repulsion it will not exist. But in in this, it will be anti-clockwise as well as anti-clockwise. So one is moving on the opposite side and second one is moving on its opposite side, so it will exist. So the correct option will be this one.